Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, very good morning, and do let me know if I'm clearly visible and audible to all of you or not. Yes, students, everybody. So as you have your schools as well, right? So we'll be doing. I will not be taking much of your time. So these are 13 most selected, most important questions, right? To revise coordination chemistry, and these are not previous year questions, right? Some of them will be little bit higher than previous year questions, some of them will be of the same level of previous year questions, because we want to be prepared for every single thing that they can ask you in the exam, right? And that is why we are taking these sessions, right? So coordination chemistry, one of the most important chapters of JEE Mains chemistry. Let's do the questions here. If you all are ready for that, yes, Captain Shreyas is also here. He's also, there with all of you, revising all the things, right? So last 2 days you did physics. Today, 2 days, it is about chemistry, and next 2 days will be mathematics, right? So everybody, let's start with the session. Everybody fill the green hearts in the chat box, fires in the chat box, so that I can see your energies in the chat box. Yes, everybody. Yes, good morning, Capto. Yes, everyone. Suhail, Sabri, Rajesh, then Suhail, Baka, Real, Sri, Abu. Yes. Okay. So let's see. The first question on your screen. Oh my God, ma'am. That's such a complicated question, ma'am. Ma'am, I don't want to see this question, ma'am. Let's skip this. This is a simple question. Some question, by the look of it, you will feel, oh my God, that's such a difficult question. But in reality, it's easy only. It's based on chelate effect. It's based on more the number of rings, more the, if one ring is 3-membered, other ring is 5-membered, then what you will prefer? You will prefer 5-membered ring. If let's say in one compound you have 2 rings, in other compound you have 3 rings, in other compound you have 5 rings. So more the number of rings, because of the bidentate, tridentate, tetradentate ligand, more the number of ligand, more the number of rings you have, more is going to be the stability here, right? So they are saying reaction of hydrated cadmium ion with different ligand is represented as below. But for that, you need to understand what is En and what is tri-En. So let me just tell you that before. What is En and what is tri-En, right? See, En is ethylene diamine, so that will be C and C, this will be N and this will be N. That is the value of En. This will be N and this will be N, so I'll be just drawing the hydrogens here, 1, 2, 3, 4, 1, 2, 3, 4, and this. This is En. This is the ligand En, ethylene diamine. Tri-En means triethylene diamine. Okay. So in this case, what you have, 3-ethylene. Okay. This is, I'll be drawing this here. This is 1-ethylene here, 1-ethylene here, 1-ethylene. That means ethylenes are 3. Now this is connected by a nitrogen, right? This is connected by a nitrogen, and this is having 1 nitrogen here in the end. And now just fill the hydrogens here. This is H2, this is H2, this is H2, this is H, and this is H2, H2, this is H, this is H2, this is H2. When you want to draw 3 enes, then you will write tris. You will not write tri, you will write tris. Okay, so that is the difference. So this is your triene, right? Now, what kind of compound they will form with cadmium? Let's understand that. If you talk about the compound that En is going to form, then understand, if this is cadmium, right? Then 2 nitrogens will donate here, and there will be another En here. So it is bis En, another En. This is H2, this is H2. Wait a minute. If you see, this is actually forming a very beautiful ring here, isn't it? These are forming a very beautiful ring here, right? So if you see, if you have cadmium complex with En, right? Cadmium complex with En, because En wants to have 4 donating sites, and that is the reason it will form cadmium En twice. So you can see here, you can see 2 rings are formed, 2 rings are formed, isn't it? What about this? Now you have donating site, nitrogen is the donating site. This is the cadmium. This is first donating site, this is second, and this is third donating site. This is fourth donating site, and that is how you have 4 donating sites for cadmium in case of trien. And how many number of ligands are attached? Only one ligand is attached. So this is actually a complex of CD trien. Only one ligand is attached here, and you will also see that here 3 rings are formed. So here 3 rings are formed, right? Okay, here 3 rings are formed, here 2 rings are. Which is going to be more stable, guys? Tell me, which is going to be more stable? Definitely the one with more rings, right? So we know what kind of complex is formed with En, and what kind of complex is formed with this. And what kind of complex will be formed with CH3NH? It has only one donating site. So this is your cadmium. Now 4 donating sites will come from each NH2CH3. Each NH2CH3 is going to give you one donating site here. The rule is that we just have to complete its 4 donating sites. That's it. Whatever ligands are given to us, according to that, we can see here you have no ring. And here, what is the complex that you are forming? CdNH2CH3, and this is 4. This is the complex that you have. So here you can see, in this case, there is 0 ring. In this case, there is, with En, there was 2 rings, right? And in this case, there is 3 ring. Now tell me which one is more stable. Correct order of magnitude of negative delta G. Ma'am, negative delta G, but we are talking about what? Stability. What is negative delta G? Delta G represents, when delta G is negative, that means it is a spontaneous process, if you know from thermodynamics. And spontaneous means stability is there. So this is what they are saying, right? So they are asking you about simply stability here. It's just that the way of writing it is different. And when these kind of questions are asked, usually students think, oh my god, that's such a complicated question. But in reality, this is a core conceptual question, right? You will see that Z is greater than Y, then X. So answer is going to be A is the correct answer, isn't it? They have asked you stability in the form of delta G negative in a different way. And here they have just asked you about how many rings are formed here, about the chelation effect. So that is completely based on the chelation effect here. Right, everybody? Clear? Clear? If that is clear, write A in the chat box, right? If you're clear with this, yes, that okay, this is the question and that is how you're going to answer this, right? So you will not see like normal questions here. I have picked some really interesting questions for you so that your brain, this brain can open up a bit, right? Okay, yes. Which one of the following has largest number of isomers? I think this one you can answer. This one you can answer. Largest number of isomers, which one will have? Let's see. If you talk about this particular complex here, that is COEN, that is nothing but this is M of AA, because this is a symmetrical. En is a symmetrical bidentate ligand. So this is AA twice, this is B2, right? In this case, you have 2 forms here. One is cis, other is trans. If you see, this is M. Now here En is bidentate. So 2En means total 4 and this means 2. So that means total 6 coordination number you have, right? So this will be a octahedral site. Either En can be here and this will be Cl or Cl. This will be your trans, and either there can be cis. Ma'am, what is cis? Cis means this will be M, this will be 1, 2, 3, 4, 5, 6. And cis means 2 ENs are next to each other. This is Cl, this is Cl. Now, definitely 2 geometrical isomers it has, right? What about optical isomers? If you see this here, trans will have no optical isomer, but cis is going to show you optical isomer. How it is going to show you optical isomer? If I take this as X and this as Y, right? Let's make a mirror image of this. Let's make a mirror image of this. Just make like your hands, make the mirror image of this, right? So if you see, you make the mirror image, this will be M. This is 1, 2, 3, 4, 5, 6. And here if you see, this will come to this side, this will come to this side. This is Cl, this is Cl. So you just have to see, are they non-superimposable or they are superimposable, right? Now I am going to rotate it. Now, so I can see it is non-superimposable. But what if after rotation it becomes superimposable? So I'll have to see that as well. You can't just say with this one, ma'am, okay, this is non-superimposable. I have to rotate it by 180 degree. So rotation means I will just do the opposite. If this is X here, this will be X here. If this is Cl, this will be Cl here. If this is Cl here, Cl will be here. If this is Y here, Y will be here. Are they superimposable? Definitely not. Can you put it here? This Y and Y is superimposable. Cl, Cl and this X is not superimposable. Beta, what is this X and Y? This is, I'm just telling you that they are in different X's. In 3D, you can see the structure and then answer. But in 2D, in the exam, this is the way you see that whether it's superimposable or it's non-superimposable. You make the mirror image. Here you can see easily, you can draw a plane of symmetry. So this is whenever there is POS present, that means definitely it's not optical isomer. Here it is not clear. I can see it is not present, but I have to also then make the mirror image and confirm that thing. So I have made the mirror image. Mirror image I have made Y, Y, this is X, X, this is Cl, Cl. Then I will rotate it. Whenever you rotate it to 180 degree, everything will become opposite. X will come to this side, Y will come to this side, Cl will be opposite here, right? As you can see, these two are non-superimposable, so definitely the cis isomer is showing optical isomer. So answer will be, it is definitely showing optical isomer. So there are two optical isomer. Now you will think that total 4 stereo isomer. No. Whenever we calculate stereoisomer, we say geometrical isomer plus optical isomer by 2. Because this is 1, this is 2, and this is the third one. So this one is also geometrical isomer, this one is also optical isomer. So answer is going to be 3, right? So answer is D. But ma'am, what about these things? What about this BA5Cl? In case of A5Cl, you won't be able to make cis and trans only. So that is definitely ruled out. In this case, you'll be able to make the trans here. If you see this case, this is Ma4 Cl2. I'll just draw this here. Where should I draw it? Wait a minute. Right? Wait a minute. I'll just draw this here. Right? In this case, because I want to show you other, options that are there. If you see this in this case, which of the following is largest number of isomer? This is definitely not true. And what about this one? This is Ma4, 1, 2, 3, 4, 5, 6, A1, 2, 3, 4, right? This is B and B. This can be trans and you can have a cis isomer. This is BB, this is AAAA. Okay. So you have trans, which definitely has POS, so optical isomer is not present. And in this case as well, if you see in this case as well, you have a space where POS is present here. Because if you see this like this, if you see it like this, okay, I'll just show you as well. I don't want to talk to you in imagination. If I see this here, let's see. Let's see if we can make an optical isomer here or not. So just give me a second. In the square planar positions, you have 3A and 1B. So I'll be writing it like this. 3A and 1B is there. Then 1B is here. And then 1A is also here. Okay. Yes. Now this is the structure that you have. If you see, this is the structure that you have, right? Now can you see directly there is a POS present? Can you see this POS is present? When you cut the POS, when you cut this plane of symmetry, it is divided into equal half. To in 2D, maybe it is not visible to you, but it is actually cutting into equal half. So POS is definitely present. POS is present here as well, so optical isomerism is not existing. So this shows only two isomers. This shows three isomers, right? And similarly, if you talk about this one, this is 2, 3, and this is your square planar geometry. And square planar geometry always has a POS. Square planar geometry doesn't matter whether you have all the atoms different or same, it will always have this POS that is passing. So it will never show any optical isomer. So eventually it is going to be less than this one only, right? Okay. Yes, it will show two geometrical isomers, right? But it will not show you any optical isomer. So answer is D is the correct answer, which is showing geometrical plus optical isomer, right? Okay. Yes. Now let's see the next one. If the number of geometrical isomers of the complex compound this is X and number of hybrid orbitals used in the hybridization is Y, then what is the answer? Now this data you must remember, I have also told you in detailed video, A, B, C, D, E, F, right? This always has this, you don't have to draw the structures and all. You must remember that geometrical isomers here are 50, right? Geometrical, yes, 15 geometrical isomers. And if I say 15 geometrical isomers, so they are saying number of geometrical isomers is X, that means X is 15. What is a hybridization? How many orbitals are involved in hybridization? If you see, the coordination number is 6. For 6 coordination number, either it can be D2sp3 or it can be sp3d2. Both of them are 3, 4, 5, 6. Both of them have number of hybrid orbitals as 6. So answer is going to be X plus Y, that is 15 plus 6, that is 21 is the correct answer. Is that clear? Is that clear, everybody? Right? So let's see the next question. That is 21 is the correct answer here. Next question is a question where you have mole concept involved, and it is based on Werner's theory, right? So this kind of question where mole concept is involved with either organic chemistry or inorganic chemistry are very important. These are not under, oh my god ma'am, this question is out of the box. It's quite a simple question, but right, the concept that is involved here, some of the students might get stuck here, right? So let's see this. If you see, on treatment of 100 milliliters of this much of this complex with excess of AgNO3, this much of AgCl is formed. Now what we will do, firstly we will calculate the number of moles of complex, then we will calculate how many moles of AgCl is formed from there. So if you see molarity, because here molarity is given, molarity is equals to number of moles divided by volume is in milliliter, then this will be multiplied by 1000. So number of moles will be, this is molarity into volume in milliliter divided by 1000. Yes, okay. Now number of moles of the complex, tell me what is the molarity given to you, that is 0.1, right? What is the volume in milliliter? 100, and this is 1000. You cancel this and you will have 0.01 moles of 0.01 moles of complex. Now let's understand, if 0.01 complex is there, then what is the number of moles of AgCl? Mass is given 4.305 and the molar mass of AgCl is 143. Okay, and when you will solve this, I've already done the calculation for you, this will be 0.03. Okay, now see one thing, when you have 1 mole of complex, you have 3 moles of AgCl. According to Werner's theory, those Cl will be taken as PPT after the reaction with AgNO3, which are outside the complex. That means 3Cl are outside the complex, right? If 3Cl are outside the complex, right, then let's just make this is cobalt. That means this is going to be cobalt. This is NH3. And how many ammonia you have? 6 ammonia. This is the complex. And if you see the charge over here, what is the positive charge on the complex? If this is 3, this will be +3, and this is -1. So charge is going to be +3 is the charge. Okay, right? So that is a fusion of mole concept with Werner's theory, right? That was like a very interesting question that they can ask you, right? Next question, let us see if you can do this yourself or not. Which of the following ions are optically active? Now tell me, optically active compound. That means we just have to see POS should not be present here. POS should not be present. Ma'am, where POS is not present? Let's see everybody. Where POS is not present? Everybody in the chat box. If you see here, definitely you have trans POS directly I can see is present. So that means here the POS is present, optical isomerism will not be shown. If you see this here as well, POS is present, optical isomerism is not shown here, right? So that is why you will say optical isomerism is not present. What about this one and this one? In this case, I have just told you this, we have discussed this. This is cis compound, and that is cis MAA twice B2. Haven't we seen this? I have told you this here as well. If you remember, I have, that's why you were asking, ma'am, why so much in detail, right? Because we have another question also, right? And detail only I'll teach, right? So this particular question, if you see, this trans does not show, but cis is going to show you optical isomerism here. So you will write that yes, definitely second is definitely going to show optical isomerism. Now let's see whether third also shows, because in that answer can vary, either B or C, it can vary. Tell me about this one. Usually most of the cases students think that ma'am this will show, ma'am this will not show, ma'am. Ma'am, easily, ma'am, this is all symmetrical. Ma'am, if I draw a plane of symmetry here, ma'am, symmetry. No, that is a very wrong way of telling that this will show symmetry. Okay, so let's see. Same line, same way we are going to see. This is nothing but MAA thrice. And how you're going to see MAA thrice? This is M1, 2, 3, 4, 5. Now, if you see, I'll just draw firstly, all the initial structures here. This is M1, 2, 3, 4, 5. Now, if you see, this is going to be AA thrice means 1, 2, 3, right? Now, when you draw the mirror image of this one, this will be 1, this will be 2, and this will be 3. Now, this is the mirror image. This is the mirror image. Now, we are going to rotate it. Now we are going to rotate it. Now see one thing. Whenever you are doing these things, you have to take care of the x's that are there. Okay, x's. Students who are answering B correct answer, you have to look for this one. X's you have to see. This is x, let's say this is y, this is z. They all are in different x's. Now what you will do, if this is y, this will become y axis. This is x, this will become x axis. This is z, this will become z axis. Now you rotate it. Rotation means everything will be opposite at 180 degree. If this is here, this will be here, right? This is y, so you can just write it that this is y, right? Then if this is here, this will be here, and this will be z, and this will be z. And here, last one is, if x is here, then x will be here in 180 degree rotation, which will become opposite. So this is x. Can you see this one and this one? When you don't write the x's here, you will see they are superimposable. But now if you see x overlapping z, z overlapping x, they are non-superimposable. They are non-superimposable. So if they are non-superimposable, that means we can say they are optical isomers. Now the answer will change here. Now tell me, this is optical isomer, it is showing. So answer will be second and third is the correct answer. C is the correct answer. Okay, right? Everybody clear? And have you hit on the like button or not? Right, it's at 6 morning, 6 a.m. in the morning. I have just woke up for you guys, right? Otherwise I am a person who always wakes up at 10 or 11, right? So this is only for you. Let's see the next one over here, that is which of the following statements are correct. Now let's see these statements one by one. The oxidation state of iron in sodium nitroprusside. Now this question is actually multiple correct answer, but in your JEE you don't have multiple correct answer in mains. That is why, you know what kind of options they can give you. First option is the statement 1, 3, 4 are correct, okay, like this. But here we'll, because we are doing the practice only, so you just need to tell me which of the following is the correct answer. Okay, the multiple statements are there, 4 of them also can be correct. Understood now in JEE how they can ask you the question. Further they will give you the options to tell that 1, 2, 3 is correct, 1 and 2 is correct, all of them are correct, like that. So if you see the oxidation number here, that will become, because this is 2, this will become -2. So this is x minus 5 plus 1 is equals to -2. So this will become x is equals to x minus 4 is equals to -2, x is equals to +2. Right? So definitely this is the correct statement. AgNH3 twice is a linear. Definitely it is linear, because when you have two ligands, the only option it is left with is linear, right? So that means it is going to show you sp hybridization and it is going to be linear. This is also the correct option. Third is you have FeH2O6. Now this is very important, because why this last two options are important? Because yes, then see, one of the student has written it here, that is Sadhguru has written it here. Ma'am, water is a weak field ligand. Ma'am, so both of them it will behave like a weak field ligand, because water is a weak field ligand in spectrochemical series. But guys, that's the case of exceptions, and that is why I have written it for you over here, all the important exceptions, right? And from these exceptions, can you pick this one particular thing here? CO, when bonded with water and oxalate, it is acting as a strong field ligand. All the exceptions are important. Go through this PDF, will be provided to you in the description box. So that means here water will be acting as a weak field ligand. But in case of cobalt 3 positive, that is here, cobalt is in 3 positive oxidation state only, water will behave as a strong field ligand, and hence it will give you sp3d2, because strong field means no, wait a minute. Strong field means it will cause pairing, and because of pairing it will give you d2sp3. Okay, and here it is weak field, and that is why it is going to give you sp3d2, because there is no pairing here, so what you will tell me? Because of the exception here, the answer has changed, right? So answer is A, B and C are the correct statements. No, A, B, D are the correct statement. A, B, D are the correct statement. C is the incorrect statement, right? Okay. Right, everybody? Okay. If you don't know that water in cobalt 3 positive acts as a strong field ligand, then you would have written A and B are the correct statement and D is not the correct statement, right? And this is where, right, exceptions plays a very important role in organic chemistry, and that's why I have written all the exceptions of VBT theory over here, right? Okay, now let's see the next question here, that is, for which of the following DN configuration octahedral complex cannot be classified as high spin, low spin? That means no matter pairing is there, non-pairing is there, it will always be same. Now for that, draw the orbitals. This is T2G, this is EG orbital. Now if you see guys, if I fill 3, if I do the pairing, it will be this. If I don't do the pairing, it will be this. So that means we cannot define high spin, low spin for D3. If I talk about D5, right? In case of D5, 1, 2, 3, 4, 5, if there is pairing. If there is no pairing, it will be 1, 2, 3, 4, 5. That means for D5, not possible. For D6 again, 1, 2, 3, 4, 5, 6. And if you have non-pairing, it will be 4, 5, 6. They are different, right? What about D8? 1, 2, 3, 4, 5, 6, 7, 8. It is like this. Now, if I don't cause any, if I cause pairing, that will be 1, 2, 3, 4, 5, 6, 7, 8. Isn't it the same? Yes. So that is the reason we'll say D3 and D8. We can't define high spin, low spin here. So answer will be first and fourth, that is C is the correct answer here. Right, everybody? Tell me, is that clear? Is that clear, everyone? Now let's see, based on CFSE. Based on CFSE, let's understand. Yes. This is based on whether CFSE will be more. From this one question, your brain will open up a little bit, right? Okay, let's see this, right? Which of the following order of CFSE is incorrect here? One by one, I'm going to see the options here. First option is ENNH3H2O. Now, from the spectrochemical series, we know that this is the correct order because stronger is En, then you have NH3, then you have water. So this is definitely the correct order here. So I can write, they are asking you incorrect, so you can say this is the correct order. What about PT, PD and nickel? Now in the second option, ligand is same, but the central metal atom is different. And for this, you must remember that 3D has less than 4D, then 5D has maximum CFSE. And this belongs to 3D series, this belongs to 4D series, and this belongs to 5D series. So you can say this over here that definitely this is correct because down the group of the 3D, 4D to 5D, the CFSE increases, right? Next is DMG you have and EN you have. Now this is very important and interesting point here that with DMG, nickel will form square planar complex. And you know, with En, what kind of complex will be formed? Nickel with En will form octahedral complex. Nickel with En is not able to form square. This is not possible only because nickel is not that strong, right? This DMG is very strong ligand. That is the reason it can form this square planar complex, and that is why here octahedral complex is formed. And this is also from the exception as well. Or you can just directly remember that DMG is more strong as compared to En. From there also this will be incorrect. And you can also remember it from here that always square planar has more CFSE as compared to octahedral, and that is the reason also this is incorrect here. This should be like this. Okay. Then last is oxalate and En, and we all know that En is definitely more stronger as compared to oxalate. So definitely answer is true here, right? So answer will be C is the incorrect one, and that is why C is the correct option here. Right, everybody? Right, this is the structure of DMG with nickel, that is a square planar complex, right? Okay, let's see the next one here. Let's see the next one here. Let's see the next one, guys. Okay, how many questions we are left with? Some 3-4 questions, right? Interesting. Let's see. Let's see, everybody. Let's see that. Now, if you see this particular thing here, this is the complex. 4 complexes are given to you. One by one, they are saying that which one of the following is correct for all of them. Okay, so one by one, we are going to see this. First is, now these are the options, very complicated options here they have given you, right? Now, one by one, we are going to see which one is correct, which one is not correct. So let's see that. If you see this particular complex, chromium 3 positive, now because this ligand is 0 with 0, it is a neutral ligand, so chromium will be in the 3 positive state. Whenever chromium is in 3 positive state, tell me what is chromium? Chromium is 4s1 3d5. In the 3 positive state, chromium will be 3d3, right? Now, chromium is 3d3. When you say the octahedral, right, this is octahedral, 3d3, and this NH3 is a You can say it is a weak field ligand here only. So it will be whether it's strong or weak field. 3D3 is always going to look like this. So it will going to be T2G is going to be 3 and EG is going to be 0. And always remember the formula of CFSE is minus 0.4 T2G electrons multiplied plus 0.6 EG. Now this EG is 0 and here that's why we have written minus 0.4 into 3, that is minus 1.2 is the correct answer here, right? What about the second one? What about the second one? You have copper NH36. Now in this case you have to tell me that in case of copper, again copper is what? Copper is 4s1 3d9. You take out 2 electrons here from copper. 2 electrons, this will be 10. You take out 2 electrons from copper and this is going to be 3d9, right? Now in case of 3d9, what you will have 1, 2, 3, 4, 5, 6, right? Because it is going to cause the pairing, so it will be 1, 2, 3. Now whenever you have copper 2 positive, NH3 will start behaving as a strong field ligand. And this I have written on my exception table as well here if you see. Right? Ma'am, how do I remember the exception table? This is the thing. Copper this is acting as strong field ligand and there must be NH3 as well that is behaving as a strong field ligand. Right? 3D series up to this state from outer octave up to NH3 in the spectrochemical series. Up to NH3 they behave like a strong field ligand, right? Okay, so that was here, right? So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you can say now you will multiply minus 0.4 with 6 because 6 electrons are in T2G. And in EG you have 3 electrons, so you will multiply this with 3 and you will get your answer here, right? Next is you have iron and water. Now if you see iron is atomic number 26, so it is 4s2 3d6. You take out, because this is 0, this will be plus 3. You take out 3 electrons, this will become 3d5. Now 3d5 and weak field ligand, what it will do? Water is a weak field ligand. It will be 1, 2, 3, 4, 5. So in T2G, you have 3 electrons. In EG, you have 2 electrons. Put the values and you will get your answer of CFSE here. Last one is this one. That is IRF6. Now in this case as well, what you will do, you will just see, even if you don't know, ma'am, how do I define, I don't know the IR, where it is placed in the series. See, simple thing is, just remember to which group it is there, right? To which particular group it is there in the series, right? According to that, you can just write the electronic configuration. After losing 3 electrons, it will become 5d6. And then you can just, this is T2G, all ligands are strong field ligands here, act as a strong field ligands for the 5D series. This also I have written in the this particular exception. Compounds of this compound prefers this. Why? Because 5D and 4D, down the group what is happening, the CFSE value is increasing, and that is the reason for 5D elements, that is, this is a 5D element, and that is the reason for a 5D element, weak field are also behaving as strong field. All the weak field are behaving as strong field, and that is the reason here you will have 1, 2, 3, even though it is water, but here it will be 1, 2, 3, 4, 5, 6. So you will have 6 electrons here in T2G and 0 in EG, and that's how you have the value here, right? Then all you have to do is match the following and you will get your answer as C as the correct answer. Okay, yes everybody. Now let's see the next question here, that is correct sequence of CO bond order in the given compounds. Now remember that CO bond order depends upon, it is actually inversely proportional to the bonding. So bond order is inversely proportional to the back bonding. So if you see, if someone has more electrons, they'll be able to donate more, they will have less bond order, okay? So that is the reason this is an anion, this is an anionic compound. And anionic compound always, if I talk about the bonding, extent of bonding will be maximum in case of S, right? Then it will be neutral, that is P. This is anionic, right? That's why it is maximum. Then this one is neutral, right? In neutral, it will be less than anionic. Now, in this case, it is free carbonyl, and in this case, this carbonyl is donating. Here it had more electrons. Here it had so many 5 carbonyls. Here there is free carbonyl. In case of free carbonyl, it is still better than that carbonyl which is already donating to someone. So here back bonding will be even less. So you can say then it will be Q, then the last will be R, and the extent of bond order will be opposite here. Bond order is opposite, so it will be S, then wait a minute, this will be R, then Q, then P, then S. R, Q, P, S, that is D is the correct answer here. Got it, na? Anionic, then neutral, then you have free, then you have sigma donation carbonyl. Okay, I'll just write this here as well. Firstly, you have anionic, then you have neutral, right? Then you have free carbonyl, then you have sigma donor carbonyl. Okay, this is the extent of back bonding. This is the extent of back bonding. Okay, right, everybody? Yes. So answer will be D is the correct answer. Next question is, how many geometrical isomers are possible for this particular complex? Right? Tell me. The complex is MAB, then AB2, right? That means what you have here is, you have a bidentate ligand which is unsymmetrical here, right? So this you must remember, as it is only whenever you have AB twice, total 6 geometrical isomers are possible in this case. I'll also show you what are these 6 geometrical isomers that are possible. If you see, in this case it is a cis form, right? Then this form, when it is AB and this is AB here, and this is A and B, this is B and A, that is another form. Then if it is there, but in front of this is AB, right? This becomes opposite. If this is AB, this becomes BA, then that is your trans isomer. Here this is AB, this is AB. Now there also AA are next to each other, so that is also trans isomer, right? Okay. Here if you see, here it is AB, and this is, so definitely it is showing only that it is trans isomer, and this is also showing only that it is trans isomer. So all these cases are possible, either AB or AB BA, right? So these are the 6 category that you have. Or you can just directly remember that, okay, this shows 6 geometrical isomer, and I have already given you chart also when we were doing coordination chemistry, right? Most stable ion here in this complex, tell me guys, which is the most stable ion, right? Definitely this is for JEE aspirants only, right? Most stable ion here, which one will be most stable? The one that has strong field ligand. I know you can answer this question I have specially kept for you guys. Last 2 questions I have kept for you because I know you can answer this after so much of things. Now you can easily answer this. This is based on spectrochemical series. More is the stronger is the field, more will be the CFSE, more will be the stability. That means here we can see all of them. CN is maximum stable. Why? Because it's a strongest field. So answer will be C is the correct answer. That's amazing. Very good, very good, very good, very good. And I see you don't hit the like button. You have just made so less likes here. Very disappointing, very disappointing. Those who are watching this right now, hit the like button. Live watching is double as compared to the likes here. That's very sad. So, which of the following ions has maximum magnetic moment? Magnetic moment. How do you answer magnetic moment? Let's see. If you see which of the following has maximum magnetic moment, so I'll just define it. Firstly, manganese. Manganese, the electronic configuration is 4s2 3d5, and manganese 2 positive is nothing but it is 3d5. Okay, manganese 2 positive is nothing but it is 3d5. Now here in this case it will have 5 unpaired electron, so n is 5, that is mu is equals to 5.9. so you just remember this is mb. This here iron is 4s2 3d6. Iron 2 positive will be, iron 2 positive will be 3d6. So it will be 1, 2, 3, 4, 5, 6. That means 4 unpaired electrons. More the number of unpaired electron, more will be the magnetic moment. Like here magnetic moment is 5.9. Here magnetic moment is 4.9. They are asking you the maximum. Maximum we already know it is manganese, because more than that magnetic moment can't be there. So it is going to be this only. But let's see others as well. Titanium is 4s2 3d2. Right? It is 22 atomic number. So titanium 2 positive is 3d2. That is number of unpaired electron is 2. Mu is going to be 2.8. Right? Then the last one is chromium. That is 4s1 3d5. You take out 2 electrons, it will become 3d4. So number of unpaired electron is 4. Mu is going to be 4.9. So definitely answer is going to be A is the correct answer here. Right, everybody? Do let me know. Is that clear? Now this is your homework question. Right? This is your homework question, everyone. Right? This is, and I want all of you to do your homework. Right? If you're not doing your homework, you are literally betraying me. Right? I yesterday took a class from 8:30 to 10 in the Sigma batch, right? After that, I worked on your PPT, selected the questions for you. Then I woke up at 6, no, not actually at 6 p.m., not actually at 6 a.m. I woke up at 5:30 only for you guys, right? If you, and all you have to do is do your homework, right? That's all we are asking for you to do. This is the question. You have PQR. You have to write the, according to this spin only magnetic moment, what is the value, right? Find out now. All of these are weak field ligands only, right? And that's how you will answer, right, everybody? Let's see how many of you will answer this in the chat box. And also, yes, do hit the like button, share this CYQ series with your friends as well, right? So that they can also get benefited. Before the school, now you have completed one class, so that relaxation will be there, that I have already in the morning when you study something, already there is that relaxation that I have studied something today, right? I have studied some really good questions today, right? So that is a very good revision of the chapter, right? Without even touching the theory, we are trying to revise every single corner of coordination chemistry. I have tried to take up questions from, right? So that's it for today. Now hit the like button, comment down the homework in the comment section, and I'll wait for you tomorrow for electrochemistry questions, right? Okay, so see you all tomorrow for electrochemistry questions. I am waiting for your answers in the comment section. If I don't see how many comments I want to see, I want to see 70 plus comments in the comment section. 70 plus comments writing the homework. I want to see that with green hearts in the comment section, right? That will be my Guru Dakshina. This is the gift that you can give me, right? Because we are doing so much for you, right? Okay then guys, bye bye, take care, and all the best for today, this day. Because you have started the day with such a beautiful thing, you have learned something new, right? You have done already 1 hour of practice questions, so your day is going to be awesome. All the best. And for if you are JEE 2026 aspirant, then guys, today at 8 a.m. I will be taking your chemical equilibrium part 2, where we will be discussing dissociation constant, degree of dissociation, and KP-Kc relations, and Lee-Chartier principle, right? So if you want to revise it, you can come in the class at 8 p.m. as well. So see you all. Bye bye. All the best for your day. Bye bye. And one more thing, I forgot to tell you that. What is that? Wait a minute. Before going, one more thing I want to tell you. How many you have schools right now? How many you have schools at this point? Okay, ma'am, what is the thing, ma'am, you want to tell us, right? So guys, over here, right, if you see this, ask with any doubts, the questions, the doubts that you have related to this particular session, you can ask over here, and the ppt PDF will be provided here only. And when you go here in the live section, right, today at 6 p.m. Sher sir is going to tell you something very interesting, right? That is your rank booster Eklavya test series, right? So all the details will be today mentioned today at 6 p.m. in the live session, right? Okay, everybody, tell me. So that's it for today. Now I'll take your leave. Bye bye.